1, 2, 3, 4, 5, 6, 7, 8, 9.
Welcome to Maths Brother, a show for all you matriculants. Take your pen and papers out, activate your maths brains, and join me as I'll be solving maths problems. So before you do that, I want you to go out and tell everybody that you found a maths brother that goes across the universe, finds maths problems, brings them here, and breaks them down into maths solutions right in your face. That has to be amazing. We are now on question 2.2.2. It says, determine all the possible values of n for which the sum of the first n terms of this sequence is greater than 31. So we're working from the sequence that's given to us in the problem, which the sequence is 16, right? And then we have an 8 and we have a 4. These are the first three terms of the sequence. It continues, obviously, in that order. You'll have 4 divided. This is 16 divided by 2, which gives you an 8. 8 divided by 2, it gives you a 4. 4 divided by 2 gives you a 1. So it's going to continue, like you're going to get a 1, you're going to get a half. So all the way up to infinity, if that's what they want you to write. So right here, they want you to write down the sum, or basically the values of n that possibly give you a sum that is greater than 31. So how do we write it down mathematically? So a sum that is sum of n terms, well, we want to know what the n is, greater than 31. I recall that you guys have learned how to actually find the sum of a geometric sequence. The sum of a geometric sequence is given by, let me just write it down neatly for you here, given by a bracket 1 minus r to the power of n, close bracket, all to the power of 1 minus n. This is the formula that's given to you guys. They give it to you so that you can use it when you want to sum up all the numbers that occur in a geometric sequence. So in this case, we have our first term being 16. I'm going to write that down. Our first term being 16. Bracket 1. What is our r? Our r we calculated from the previous question, which was 1 over 2 all to the power of n divided by 1 minus 1 over 2. And please guys, remember, r can never be 1, because if you have a 1 here, then this whole thing is wrong. It doesn't make sense mathematically, because you'll be dividing by 0. Division by 0 is undefined. So we're going to continue with the question. Right here at this point, you need to remember what you're trying to achieve. You're trying to make this sum. Find the values of n that make this sum greater than 31. So it's just basic mathematics going all the way down here. So now we're at a point where we have 16 bracket 1 minus our r was 1 over 2 to the power of n bracket all to the power of 1 over 2. I'm not going to write the 1 over 2 because we know that it has to be transferred to the right hand side. And that would give us at 31, that's what we're working with, the 31 bigger than a 31. So it will give us a 31 divided, multiplied in this case by 1 over 2. So we know that we need to destroy the 16 on the left hand side to more like free the side to allow us to find the solution for n. So we have our bracket here being 1 minus 1 over 2 to the power of n bigger than, what do we have? Yeah, it'll just sum up to 31 over 32, because 16 multiplied by 2 will give us a 32. So we take the 1 to the other side and we are left with a negative bracket 1 over 2 to the power of n bigger than 31 over 32 minus 1. And that in a nutshell will give us minus 1 over 32. The negatives will cancel. I'm sure you guys know that. When the negatives have cancelled, we go back into a lesson we are very familiar with, which is exponential laws. When we have, and especially when you're applying them in solving equations, when we have exponents with the same base, then they are, when we have the bases being equal, then the exponents are equated and a solution could be found from it. So in this case, we have an exponent which is 1 over 2. We can write it as 2 to the power of minus n, right? Which is greater than 1 over 32 will be written as 2 to the power of minus 5, because it's a division. And I hope you guys remember that. And now the exponents will be equated and we'll find our solution. So n must be greater than minus 5. the negatives cancel, and you'll be left with n must be greater than 5. So that's what it's saying. There must be more than 5 terms to get a sum of 31 or greater. So guys, we're almost done with this problem. Let's go to 2.2.3. It says calculate the sum to infinity of this sequence. So what is a sum to infinity? A sum to infinity is a sum of all the infinite terms that occur in the sequence. Obviously, it's impossible to write that down, all the numbers, and sum them up. So we have a formula that makes things super simple when you're working with an infinite geometric sequence especially. So we have our sum to infinity. Remember, this is an infinity sign. I'm sure you guys know that. That's why I'm actually smiling. Is equals to a, that's a over 1 minus r. Remember, r can never be a 1. Never be a 1. So it must be anything else besides a 1, so that you don't find the denominator to be 0. So in this case, we know what our first term is. This is a literal plug and play solution. So we know what our first term is. We're given our first term to be a 16. And then we know that 1 minus our r was 1 over 2. So that gives us 16 over 1 over 2. What is 16 over 1 over 2? Please don't say 8. This is a half. It's not 2. So there's a difference. So we'll get 16 to be multiplied by 2 in a nutshell. So the sum, all the numbers, if you sum all the infinite numbers in that geometric sequence, you will find them that they add, eventually they're adding up to a 32. That's basically it, guys. That was Matt's brother for this week. Thank you so much for tuning in. I hope you guys learned valuable lessons that you can apply in your tests and exams and in your real life. Remember, maths doesn't end in the classroom. It's a Matt's brother signing out.
1, 2, 3, 4, 5, 6, 7, 8, 9.